Introduction. Welcome to our channel AlgoExpertDude. Today, we're diving into the world of algorithms, focusing on one of the simplest and most intuitive sorting techniques, the insertion sort algorithm. By the end of this video, you'll understand how it works step by step, its complexity, comparison with other algorithms, and its pros and cons. Let's get started. Introduction to insertion sort. Insertion sort is a simple sorting algorithm that builds the final sorted array one item at a time. It's much like sorting playing cards in your hands. You pick a card and insert it into its correct position among the already sorted cards. Step-by-step process. Let's break down the insertion sort process step by step using an example. Consider the array 5, 2, 9, 1, 6. Step 1. We start with the initial array 5, 2, 9, 1, 6. Step 2. The first element, 5, is considered sorted. We move to the next element, 2. Step 3. We compare 2 with the sorted elements. Since 2 is less than 5, we shift 5 to the right and insert 2 at the beginning, 2, 5, 9, 1, 6. Step 4. Next, we move to 9. It is greater than 5, so it stays in its place. Step 5. Now, we move to 1. We compare it with the sorted part, 2, 5, 9. 1 is less than all these, so we shift them to the right and insert 1 at the beginning. 1, 2, 5, 9, 6. Step 6. Finally, we move to 6. We compare it with the sorted elements and place it between 5 and 9. And there you have it. 1, 2, 5, 6, 9. The array is now sorted using insertion sort. Complexity. Let's talk about the complexity of insertion sort. Time complexity. Best case. In the best case, when the array is already sorted, the time complexity is O, n, because we only make n comparisons. Average case. In the average case, the time complexity is O, n squared, because we need to compare and shift elements multiple times. Worst case. In the worst case, when the array is sorted in reverse order, the time complexity is also O, n squared. Space complexity. The space complexity is O, 1, because insertion sort is an in-place sorting algorithm. It requires no extra storage other than the input array. Comparison with other algorithms. How does insertion sort compare to other sorting algorithms? Bubble sort. Both bubble sort and insertion sort have O, n squared, time complexity in the average and worst cases, but insertion sort is generally more efficient. Selection sort. Like insertion sort, selection sort has O, n squared, complexity, but insertion sort is faster for partially sorted arrays. Merge sort and quick sort. Insertion sort is much slower than merge sort and quick sort, both of which have average and worst case time complexities of O, n log n. However, insertion sort has less overhead and can be faster for small or nearly sorted arrays. Pros and cons. Let's discuss the pros and cons of insertion sort. Pros. Simple to implement and understand. efficient for small data sets or nearly sorted arrays. In place and stable, meaning it doesn't require extra space and maintains the relative order of equal elements. Cons. Inefficient for large, random datasets due to n² time complexity. Not suitable for datasets where the cost of comparisons is high. Conclusion. In summary, insertion sort is a straightforward and intuitive algorithm best suited for small or nearly sorted datasets. It might not be the fastest for large datasets, but its simplicity and efficiency in certain cases make it a valuable tool in the world of algorithms. If you found this video helpful, don't forget to like, share, and subscribe for more algorithm tutorials. Next we'll continue to write the code for insertion sort in Java.